I've got a couple of functions, f of x and g of x, written up over here. And then our directions are to find and simplify a formula for these new functions that I can build out of them using arithmetic. So what we did previously is we were plugging in a particular number for x. Now, I'm just trying to come up with a general formula for this new function. So, with f of plus g of x, I can say, I know that's just f of x plus g of x. That's the definition of this new function that I get. And all I'm going to do is write down the formulas. So that's x squared plus 3x is my f of x, plus g of x is 5x minus 2. That is a formula for f plus g of x. Now, I asked you to simplify it. That means do as much of the arithmetic as you can. So here, we've got x squared plus 3x plus 5x minus 2. Those parentheses sort of told me this was f and this was g, but they weren't really necessary because I was just adding a bunch of stuff. I can see those guys are like terms. So this is going to become x squared plus 8x minus 2. So that would be the simplified formula for f plus g of x. All right, it's going to be the same basic principle for all of them. Let's just work through the next one together, and then I'll let you try the last two on your own. So for f minus g of x, that's going to be f of x minus g of x. So f of x was x squared plus 3x minus g of x was 5x minus 2. Now this set of parentheses is necessary because I'm subtracting this whole thing. The parentheses around the formula for f, not so necessary. I can drop them. To play it safe, I'll often just write each formula in parentheses and then take a look. If there's anything that I'm doing to the entire quantity in parentheses, that tells me those parentheses were necessary. If not, they weren't necessary. So here, these I can drop, x squared plus 3x. In order to get rid of these parentheses, I need to distribute that negative. So it becomes a minus 5x plus 2. And now I can go ahead and combine the like terms. So that's going to be x squared minus 2x plus 2. That is my simplified formula for f minus g of x. Okay, one thing you'll notice is once I've fully simplified it, I've combined any like terms that there are, and also I've eliminated any parentheses. I've made sure that I did what was being done to this entire thing. I distributed that negative, and then that allowed me to combine the like terms. So what I'm going to have you do is with these same functions f and g, just take a moment, pause the video, work out parts C and D. Find and simplify a formula for f times g of x, and then f divided by g of x. Part C was to find and simplify a formula for f times g of x. So I know that's just going to be f of x times g of x. So I'm just going to copy the two formulas. That's f of x was x squared plus 3x, and g of x was 5x minus 2. Now at this point, both sets of parentheses are necessary because I'm multiplying this entire thing, both terms, by this entire thing, both terms. But it's not fully simplified because I can actually do the multiplication. Okay, so I should be able to simplify it, multiply this out so that I don't need those parentheses. And since this is just 2 terms times 2 terms, it's a product of 2 binomials, I know that the silly mnemonic device that helps me remember what to do is the word FOIL. So f stands for my first terms. X squared times 5x is going to give me 5x cubed. O is for the outsides. X squared times negative 2 is negative 2x squared. I stands for the insides. 3x times 5x is going to be 15x squared. And L stands for the lasts. 3x times a negative 2 is minus 6x. You'll notice I'm very careful. That negative sign is considered part of that term. So when I multiply, I'm multiplying by a negative 2. All right, so I've multiplied it out. I want to just take a look and see, are there any like terms? Yes, those guys are both x squareds. So 5x cubed plus 13x squared minus 6x would be my final answer. Now, you might notice there's an x in each of these terms, so I could factor out an x. When I'm asking you to simplify things, I specified what I meant by that was do as much of the arithmetic as you can. Do the multiplication. So don't factor. Sometimes it's simpler to have things in factored form, okay? But if it's simplified, it's not going to be in factored form, it's going to be multiplied out. Simplify is going to mean that we've done the arithmetic as much as possible. And factoring is essentially unmultiplying. There are plenty of times when we're going to want things in factored form, but here I wanted this all multiplied out. Okay, so that's part C. Part D was to find the quotient function, f divided by g of x. So that's just f of x over g of x. And with a fraction, there are understood parentheses around the top and the bottom. So this fraction bar actually behaves as its own grouping symbol. So I can just copy these formulas. X squared plus 3x, 5x minus 2. And we're done. Okay? So in this case, there's no simplifying to be done. I'm just going to leave it this way. This is generally how I would write polynomial division like this. So sometimes when you're finding a formula, it's as simple as just copying the formulas and combining them using the appropriate arithmetic operation. But you do always want to check to see if there's some part of that arithmetic that you can simplify.